Hey, in this one, I'm gonna show you how you can encrypt all the traffic of your Zeromq sockets, because of course, so far, every message that we've transmitted over the network with those sockets has just been in plain text or plain bytes, I guess. So let me just so I've taken back the original example, publisher subscriber from day one. And I have the publisher running, and let me pull up WireGuard here, so that we can. It's already running, and let's see what happens as soon as I subscribe. So there you go. I will stop it, and so there is a bunch of packets, but we can see that somewhere in there should be. There we go. There is our hello payload. So you can see that it's in plain text, and so let's fix that. So Zeromq has various methods of authentication. There is one that uses plain password and so on and so on. But today I'll just focus on Curve, which is, I don't know, Zeromq's own little protocol, but it's based on public and secret keys, just like regular encryption, so we just use that. So, and to use it, it's very simple. You just set a bunch of options before the Zeromq bind and the Zeromq connect of your sockets, and automatically all the encryption is handled for you. You don't have to change any of your sends, any of your receives. So let's start. So to start, we need to, the way the Curve encryption works is that you have a server and you have a client, and so you need to decide which of the sockets is a server, and to do that, you set the Curve server option with a 1, which will tell that this publisher is also a Curve server. Then you need to set a secret and a public key, which is done with the setSockOpt once again. So this is not readable at all, but and this doesn't work. But let me just put it on multiple lines. Maybe that will help a bit, like so. So yeah, what happens is that you're setting the secret key and the public key. I'll tell you later on how I got these keys, but so far just assume that it's some sequence of bytes and it's my secret and my public key. So there we go, we have those. And now if let's say I restart my publisher, so it still works. But now if I launch my subscriber, you will notice that nothing happens, because of course the subscriber, well, it doesn't have a Curve enabled, and it doesn't have his own secret key. He doesn't know the public key of the server. So let's fix that. Let's fix that. So if I go on the subscriber now, it's quite similar to the publisher, as in you need to set a secret key and a public key for this subscriber. So nothing new here. Again, let me split it on multiple lines so that we can see a bit better what's going on. The new thing is that you need to also specify the server key. And the server key is simply the public key of the Curve server. So if you go back on the publisher, you will notice that this public key here is the same as this server key option that we set on the client. So let's close that. And now let's recompile and run our subscriber, and it works again. But now, if we go on Wireshark and we reset our thing, and now that we have stuff, we can check the content of the packets, and nowhere in there do we see the hello payload. So we know that everything is encrypted. So now let me do a little pause, and I will show you how to handle these keys better. Okay, so the first thing that I want to show you is how I got these keys. So those are just, if you just go in the Zeromq CURVE man page, there is some basically test keys that are generated for your test. So I just use those because it was easy. But you can generate some key pairs with Zeromq CURVE key pair, which will generate a random key pair for you, which you can then reuse in your sockets. So you just have to store that pair somewhere. And now I wanted to show you some things to make your life a bit easier. So from a secret key, you can always derive the public key. So why store the public key at all? So you can see here I modified the example slightly, where I just store the secret key here. I have a buffer for the public key, and I use the Zeromq CURVE public function, which will fill my public key buffer, and then I can just use that in as the public key. And now I just have to store the secret key somewhere and not worry about the public key. So yeah, this just works. I recompile the publisher, and then I run the subscriber. Nothing different. So now let me show you something else for the subscriber. There you go. That's my other little thing, which I already showed you, I realized. But since you can just generate a key pair from Zeromq, and since like the Curve client, like its public key and its public key can change whenever you want, unlike the server one, which needs to be known by the clients, you can just generate a key pair every time you connect for the subscriber. So yeah, this just still works, and then we have a new key pair every time we restart the application, on the client side at least. But yeah, that's all there is to know about the Curve encryption. You can use it as for encryption, also as an authentication thing, since if you keep the public key of your server secret, nobody else will be able to connect to it. So yeah, quite useful if you're gonna do something over the public internet. And yeah, hope that was useful, and I'll see you in the next one.